Okay, so this problem is asking us to find the measure of a weight scale of a man who is of mass 80 kilograms and he's in an elevator, and this is in various conditions. So to solve condition A, the elevator is moving up at a positive velocity. So to find this, we just have to find the sum of the forces, which are going to be N minus mg equals ma. And since we already know the acceleration is 0, since it's going at a constant velocity, we can already assume that this is 0. So we'd end up with N minus mg, and that's our problem. And then if we move it over, we have a new equation, N equals mg. And this is the equation we're going to be working with. So for part B, if the elevator is moving down at a constant velocity, once again, we already know that ma is going to cancel out to being 0 since the acceleration is 0. So if we do the sum of forces again, we have a negative n this time, minus mg. And we end up with the same problem, but since the elevator is going downwards, it's negative n equals mg. Now for part C, it's a little more complicated because now we have an acceleration and it's moving up at 4 meters per second squared. So now we can actually try to do F equals ma. And since we already know the sum of the forces, as we established in these first two parts, is N minus mg, we can make this N minus mg equals ma, and then by moving this equation around a bit, we get N equals mg plus ma. So the weight plus the force. And then we can just plug in the values that we're given. He has a mass of 80, and just to make gravity simpler, we can put 10 here. And the mass of 80 times the acceleration of 4 ms squared. And this will give us 800 plus 320. So we end up with a measure on the weight scale, a force of 1,120 newtons. And now in part D, to get the downward force with an elevator going down at an acceleration of negative 4 ms squared, we just do the same application, but this time the acceleration will be negative, so it will be much less. So we would have the mg plus ma again. Then we have 80 times 10 for the weight of the man, and then 80 because his mass stays the same, but the acceleration this time will be negative since it's going in the downwards direction. And we will have 800 minus 320 this time, and that leaves us with the force of 480 newtons. And then for these two problems, we would get the same result. We would just apply the same thing, and we would end up with these same forces.